Good morning, students. Welcome back to digital signal processing class. In today's class, we are going to deal with the interpolator decimeter. How do we cascade it? How do we get the output by taking the cascaded form? In that, we are going to learn where it is going to be useful. The decimeter and the interpolator. We'll do some problem and then we'll proceed with this concept, that is cascaded form of sampling rate conversion of I by D factor. So this is the things we are going to discuss in today's class. So before that, we will take the glance of the previous class, what we have discussed. In the previous class, we discussed about the downsampler or decimeter and the upsampler or interpolator. So where the downsampler is going to be used when you want to reduce the sequence length, when you want to write, when you had a sequence sampling rate is very higher, when you want to reduce the sampling rate, for that particular situations we are going for downsampling with the factor of M or D, right? Next one, upsampling. Upsampling is one of the example of interpolator. So interpolator, where we are going to use, where we want to write the sequence, which sequence, the sequence length you want to increase or you want to do the upsampling. So for that particular situations, we are going to do the upsampler. Okay, so here we are using the cascaded form of sampling rate with the factor of I by D. Okay, so see, so when I am giving x of n, this is my interpolator or upsampler, which is going to increase the sampling rate, and it is passing to the hd of z. This is the response function, impulse response functions, right? Again, the same hd of z is passing to the decimeter, which is having the factor of m, which is going to do the downsampling. So where actually we are going to use this kind of cascaded form, where whenever we want to do the sampling rate conversions with higher and lower both at a time. That means when I am having compact disc with a frequency of 44.1 kilohertz and I am having one audio tape which is 48 kilohertz, I want to convert the sampling rate of it. So meaning is that I want to divide these two. So if I want to divide it, I may not get the exact rational factor, right? So for that kind of situations, I need to write the y of n, which is a function of both interpolator as well as decimeter of n. So in order to do these things, we have to go for cascaded form. One time you have to do the increasing the sampling rate, another time you have to decrease the sampling rate, and you need to write the minimum of both the values. So when you want to do these kind of things, this is the one of the form of writing the cascaded form of interpolator as well as decimeter. Okay. So this interpolator decimeters are quite useful in digital circuitry, where you want to do the upsampling and downsampling at a time. Here you have to use the factors which is non-integers. When I divide this to 48 and 44.1, both the values, I may get this whatever the values I'm saying, 44.1 and that one, both if I divide, I may not get the exact value for it. So that's non-integer value if I'll get. Then a sampling rate conversions we have to use by I by M, which can be achieved by first performing interpolation with a factor of I, then doing the decimation with a factor M. So when you want to reach out to these things, interpolation and decimations, that can be achieved by cascading both the factors. So this will be useful for converting any kind of rational factor which having the less number of samples and more number of samples, which will be useful in designing the multi-rate DSPs, okay, where you have to do the decimeter as well as interpolator into the consideration. So after knowing this interpolation decimations, now let us do some problems based on the interpolation and decimation. Okay, so by considering this thing, I want to do the problems of interpolation as well as decimation. Means what? I want to increase the length of the sequence and decrease the length of the sequence. So let us see one problem, students. So take x of n if problem number 1, x of n is equals to 1, minus 1, 0, 2, 3, 4, 5, 9, 7, so on. This is given sequence. Okay. Downsample the sequence with m is equals to 2 and find y of n. We have to find the y of n. Okay, so here is decimeter. What is the decimeter block diagram, you know, students? Decimeter is going to do the downsampling with m, giving me the x of n, and having the function hd of z. If you want to use it, you can use it. Y of n is what? It's a function of x of mn, right? This we know for decimeter. Why I am using decimeter? Because we said it downsample. Clear? So with the factor m is equals to 2 means y of n is what? X of m. M is what? 2n. So we have to reduce the sample. So y of n, if I want to write, whatever the numbers in the second position, this number -1, 2, 4, 9, this will be eliminated. So we are going to get that 1, 0, 3, 5, 7, so on. This is called downsampling. Downsampling means reducing that particular sequence of the length. That's it, the output. So if you downsampling means we'll reduce it. If the same problem, they said it, if x of n is equals to 1, 0, 2, 3, 4, 5, 9, 7, they said to upsample or do the interpolation. They can say it in both the ways. Upsample with I is equals to 2. Okay, they said to do with interpolation. For that, what I will do it first, you note on this, then I'll show you the second one. It's important to solve these kind of problems, and they'll come in short marks question. Okay, for that particular problem, what we have to do? We have to do the upsampling. For that upsampling, what is that particular interpolation? So instead of you dividing this, what we will do? Same sequence, this is what? Interpolator. Why it is interpolator? Because it's an upsampler. With increasing the factor by I. This is, we'll write x of n by I. So what is I factor? I is 2. So we have to add zeros to it. To get the y of n, what we do? We will keep on adding 0. 1, in between these two we have to add one factor, that is 0. And 0 is as it is. Then 2 is there. So in between the 2 and 0, 1 added 0 here. Then between these two again we need to add 0. Then it is 2. Then between 2 and 3 we have to add 0. Then 3. Then between these two, 3 and 4 we have to add 0. Then 4. Then 0, then 5, then 0, then 7, 9, then 0, then 7, dash, dash, dash. This is called it as upsampler, where we are adding zeros between all the factors. Okay, this is the way we'll go for interpolator or upsampler. If they give 2, that the position we have to use it 2. If they did not give 2, instead of 2, if they give 3, then position would be third position. Okay, you try by yourself, take the own problem for interpolator and decimeter and go with upsampling as well as downsampling of the sequence. So in the next class, I am going to explain you about how do we get the upsampler and downsampler with, I will use one filter, anti-image filter we use, and we will going to proceed with TMX32600 kind of processor, where it is useful and how it will be useful. That particular part we are going to see in the next class. But before that, do some problems by your own for interpolation and decimation by changing the factor. So how the factor will be changed, students? So we have to change this factor. Instead of 2, if they gave 4, then at the 4th position we have to do it. If they gave decimeter as 3, what we will use? We will reduce third position value. This 2, 1, 2, this is 5, then this is next number we will reduce. Depends upon the factor, that particular values of that positions will be reduced. Thank you.